Hello guys, welcome to today's class. Today we'll be talking about implicit differentiation, and we have these 6 questions and we're going to solve them as they appear on the screen. Please don't forget to go through the other videos, and also don't forget to subscribe to this channel so you'll be getting more of these videos. So let's talk about the principles first before we start solving these questions. So let's talk about differentiation of implicit function. It's another method of differentiation. An implicit function in two variables x and y is one in which neither variable can be easily expressed in terms of the other. And for example, we have x cubed plus y cubed equals 2x squared. This is an implicit function. Since you cannot isolate y in order for you to differentiate x cubed, so you can't definitely do that unless you have to differentiate x and then y. So to differentiate implicit functions, there are certain rules you must follow. First of all, you differentiate with respect to x and y in dy dx, and then you make dy dx the subject of the equation, and then you must also note that differentiating y becomes dy dx. When you differentiate y, it becomes dy dx, and then differentiating y square, don't forget you multiply 2 comes down, this becomes 2y. Remember, you subtract the power given by 1, and then don't forget to write dy dx. So, and you should also know that when differentiating this power 3y cubed here, it becomes 3 times 3 is 9, and then 9 subtract the power by 1, it gives you 9y squared, and then you write again your dy dx. So you must follow these rules in order for you to be able to differentiate implicit functions. So let's illustrate this by solving some examples and some examination questions. So guys, please don't forget to like, share and comment, as this will help support the work I do. In this question, we are asked to find dy dx if x squared minus 4xy plus 7y squared equals 15. Remember, you cannot isolate y, so the only way you can solve this is by using the implicit method of differentiation. So let's get to solve this. I'm going to take my time to explain for you to get the concept. Please make sure you follow along. So let's differentiate. This becomes x squared, you differentiate x squared becomes 2x, and then you write minus 4, open a bracket, try to differentiate x. You differentiate, the first thing you do, you differentiate x, you hold y, and then you differentiate y, you hold x. Let's differentiate x. So differentiating x, is power, the coefficient is 1 times x, and then you subtract 1 by 1, you hold y, and then plus y. Make sure you differentiate y, and then you hold x. Remember, we first differentiate x and then we hold y. Now we are differentiating y, we hold x. Keep x, and then differentiating y becomes dy dx. Remember from the rule I explained just now, make sure you check the rule. Check the rules. So let's go to this one, plus, write our plus sign, 7y squared. So 2 times, try to differentiate, 7 times, differentiating y, this 2 times y, is 2 times y, and then y squared minus 2 minus 1. Remember, whenever you differentiate y, you write dy dx, and then differentiating 15, this becomes 0. So here we now have 2x minus 4. We have 1 times x raised to the power 0, y plus x dy dx. We have here 14y, 7 times 14, y 2 minus 1 is 1, so it's 14y dy dx is equals to 0. So we try to we arrange this minus 4 x raised to the power 0 is 1 times y is y plus x dy dx plus 14y dy dx plus 0. Then we expand the bracket, minus 4y minus 4 times plus minus times plus is minus 4 times x is 4x dy dx. You expand the bracket, plus 14y dy dx is equal to 0. We bring the dy dx together and then we send this one over. So this one becomes, let's first of all write 14y dy dx since it is positive, and then we write negative 4x dy dx. Then we have here plus 2x minus 4y is equal to 0. Here we try to differentiate dy dx. We try to factorize dy dx. So here, taking dy dx out, you are left with 14y minus 4x, and then we try to send this one, this becomes positive 4y, and this becomes negative because it's going over the equal to sign, minus 2x. So here we differentiate 2 out by 14, we divide 2 out by 14y minus 4x, divide it again by the same 14y minus 4x. So this cancels this. So our dy dx that we asked to find is now 4y minus 2x all upon 14y minus 4x. So this is our answer. So guys, please don't forget to like, share, comment, and also don't forget to go through the other videos. Thank you. So let's solve this question. We have to find dy dx at this point, minus 2 and minus 1. This is our x value and this is our y value. So we differentiate this using the implicit method of differentiation because we have two variables here, x and y, and we are asked to find dy dx at that point. So let's start by solving. I'm going to take my time to explain this for you to grasp the concept. So let's start. This becomes 2 times the power here, 2 times 3 the power, subtract by minus 1. Do the same thing for this. 2 comes down, 2 times 2y, 2 minus 1. Then whenever you differentiate y, make sure to include dy dx plus, now we're going to differentiate x and we keep y. Differentiating x, the coefficient here is 1, so the coefficient multiplied by x, and then you subtract the coefficient by 1. Then you keep y plus, then you differentiate y and keep x. Now we differentiate y, keep x, differentiate y, this y becomes dy dx, and then plus x. Differentiating this, it becomes 1 times x, 1 minus 1, and minus 7 differentiated 0 because this is it. So we have here 6x plus 4y dy dx plus, this is x raised to the power 0, so we're only going to be left with y plus x dy dx plus x raised to the power 0 again. This x raised to the power 0, so it's 1 and 0. So we bring dy dx together, 4y dy dx plus x dy dx, and then we write plus 6 plus 6x plus y, and then plus 1 all is equal to 0. Factorize dy dx out. We have 4y plus x divided by dx. Factorize it out. We are left with this. Dy dx is 4y plus x. All of this one becomes negative, the negative y, and then negative 1. So here we divide 2 out by 4y minus x, 4y plus x, sorry, 4y plus x, and then divide it again by 4y plus x. So we have now this cancelling this, we are left with dy dx is equal to factorize the negative sign, minus sign out, open the brackets. So if minus sign is out, this becomes positive 6x minus affect this become positive y, and this becomes positive 1. You expand this bracket again, you get the same thing. So we have 4y plus x. Now we have dy dx, and we have to find at the point minus 2 and 1. Minus 2 and 1. This is our x value and this is our y. So we substitute to find dy dx. So write dy dx is equal to, write a minus sign out, 6x is minus 2, and then plus 1, and then plus 1, all upon 4 into 1 plus into minus 2. So we have, this is now equal to minus, this is minus 12, 6 times minus 2 minus 12, this is plus 2, all upon 4 times 1 is 4, plus times minus, and then write your minus 2 over there. So we now have equal to minus sign, this is negative 10, minus 12 plus 2 is negative 10, so negative 10, and then upon 4 minus 2 is 2. We go minus times minus here is plus, so 2 into itself 1, and this is 5. So dy dx is equal to 5. So that's our answer for this question. Make sure to like this video and share, comment, and also don't forget to subscribe. So let's solve this question using the implicit method of differentiation. Since we have two variables here, x and y, and we have to find dy dx. Let's start by differentiating. For x cubed, differentiate for x cubed becomes 12x squared, 3 times 4, 12, and then 3 minus 1 is 2, minus 2 times the power here, 2 times 7, we have y, and then 2 subtract by 1. Remember, we are differentiating y, so you get dy dx minus 2 bracket, differentiate x squared is 2x, and you differentiate x squared is 2x, and then you keep y squared. Write your plus sign. Now we are going to now differentiate y squared, and then we'll keep it x squared. X squared differentiate y squared is 2 times y, and then 2 minus 1. Remember, you are differentiating y, so you write dy dx. Differentiate minus 8x is minus 8 equals 0. Then we try to write 12x squared again. 12x squared minus 14y dy dx. We have minus 2 brackets 2x y squared here plus 2 comes, this is 2x squared now. We have 2x squared y here, 2 minus 1 is 1. Then we write dy dx minus 8 is equals 0. We write 12x squared minus 14y dy dx. Expand this bracket, minus 4x y squared minus 2 times 6 is minus 4 again. Minus times plus is minus 4x squared y dy dx minus 8 is equal to 0. We bring dy dx together, minus 14 dy dx, and then minus 4x squared y x squared y dy dx, and then you bring plus 12x squared minus 4x y squared, and then minus 8, all is equals to 0. Factorize dy dx out. For this two, factorize dy dx where it's common. Remember, there is 14y here. This is minus 14y minus 4x squared y, and then this one goes, they go over the equal to sign, they become positive. This becomes positive, this becomes negative, and this becomes positive. So let's write this one first, x y squared, and then this becomes negative 12x squared, and then this becomes positive 8. So we divide 2 out by minus 14y minus 4x squared y to get rid of this. So minus 14y minus 4x squared y. This one cancels this. We are left with this minus 14y minus 4x squared y. So we have here dy dx is equal to, factorize 4, because 4 can go into itself, can go into 12. It can also go into 8. Factorize 4x y squared minus 4 into 12 is 3, x plus 2, 4 into 8 is 2, and then factorize minus sign, gets minus here. So factorize the minus sign out. This becomes 14y, it's positive 14y plus positive 4x squared y. So you can simplify this further if you want to. So here, let's say we take out 2. So let's say our final answer here, try to bring this down. 4x squared y minus 3x squared plus 2. This is now minus 2 here. Because 2 can go into 14, it can go into 4. So, and here we have y, so let's factorize 2y out. And then this becomes 7. 2 into 14 is 7 plus 2x squared. So this is our answer for this question. So guys, please don't forget to like, share, comment, and please subscribe. Thank you. So let's solve this question. We ask to find dy dx. 2x cubed, if 2x cubed minus 3y squared equals 4px, where p is a constant. Remember, this is a function involving both x and y, so we solve this using the implicit method of differentiation. So let's solve this. So this becomes 3 times 2, 6x, 3 minus 1, this becomes 6x squared, 6x squared minus 2 times 3y, and then 2 is subtracted by 1, right? dy dx, since you are differentiating y, that's the rule, 4p, and then if you differentiate x, differentiating x, since the power here is 1, this becomes 1 times x, you differentiate x and keep y. You differentiate x, keep y, write your y, and then you write plus sign. You keep x now, and then you differentiate y. Differentiating y becomes dy dx from the rule. So this one is now 6x squared minus 6y dy dx is equal to 4p. 1 times x is x raised to the power 0 is 1, 1 times y is y, plus x dy dx. So here, write again 6x squared minus 6y dy dx is equal to, expand this bracket, 4py plus 4px dy dx. So we bring this over and then send this over to the other side. So this becomes positive 6x squared minus 4py is equal to 4px dy dx. This becomes plus 6y dy dx. And then here, write again 6x squared minus 4py is equal to, factorize dy dx out. We are left with 4px plus 6y, and then we divide by 4px for us to get dy dx. Remember, cancel this, divide it again by 4px plus 6y. So we now have dy dx is equal to, factorize 2, 2 can go into 4, it can go into 6, can go, 2 can also go here, it can also go here. So you take out 2, this is now 3x squared, 2 into 6 is 3, 2 into 4 is 2, write your minus sign, minus 2py, close this bracket, all upon 4, take 2 again out, this is 2px plus 3y, so 2 cancels 2, so our answer here, dy dx is equals to now 3x squared minus 2py all upon 2px plus 3y. So this is our answer for this question. Thank you guys. Make sure you follow, subscribe, you like, and then you share. Thank you. We are asked to show that 2 in bracket x cubed plus 1 dy dx is equals to this minus. So this is what we are supposed to get when we differentiate y equals 15 all upon x cube of x cubed plus 1. So here, what we do, we're going to differentiate this implicitly, since it's going to involve 2 variables x and y. We differentiate using the implicit method. So let's try to, this is a fraction, we try to cross multiply upper 1. Remember this, you multiply this denominator here, then you multiply this denominator there also. So here, this becomes y in bracket root of, remember bracket means multiplication, x cubed plus 1 is equals to 1 times 15 is 15. So we're going to write this as x cubed plus 1 all raised to the power half is equals 15. And now we're going to differentiate. If we differentiate this, We differentiate y, it becomes dy dx. Then we keep all of this together. This is x. And then we differentiate this x cube, and then we keep y. So here, let's try to differentiate this x cube here, because since we have raised to the power half, we can't do this unless we use the chain rule. Make sure you go through chain rule. If you check my videos, you find where we talked about chain rule. So let's solve this using the chain rule method. X cubed plus 1 all raised to the power half. So here, let's say m is equals to this, and then u equals to this. So let's u is equals to x cubed plus 1, and then m will be equals to u raised to the power half. So differentiating the u, the x is equals to 3x squared. Differentiate du dx, du dx, dx squared. That will come dm du is equals to half, multiply down here, it becomes half u, and then half subtract by -1. So it gives you here half u raised to the power -half. So write this becomes, bring this one down, you know u as x cubed plus 1. So x cubed plus 1, bring it down, and then the power becomes positive. So this is what we have. It's upon 1. So let's try to now use the chain rule method differentiation, which says now the m, the x is equal to, this is now 1 upon, write this 2 x cubed plus 1 raised to the power half multiplied by this du, dy, du dx here is 3x squared, right? 3x squared. Make sure you use the chain rule, go through the videos for you to get the full concept. So this becomes 3x squared all upon 2x cubed plus 1 is about 1 over 2. So now we've differentiated x. So let's now come and solve this. I'm taking my time to explain for you guys to get the concept. So let's solve this now. So this becomes, we differentiate y and then keep this. Differentiating y becomes, from the implicit rule, dy dx. Differentiating y becomes dy dx, and then we keep x cubed plus 1 raised to the power half. And then here we keep y plus y times differentiate, you keep y, differentiate x now. Differentiate x is this value here that we've got. This is now 3x squared all upon 2 in bracket x cubed plus 1 all raised to the power half. Differentiating 15 becomes 0. So here we have dy dx is equals to x cubed plus 1 raised to the power half plus, this is now y times 3x squared, becomes 3x squared y all upon 2x cubed plus 1 raised to the power half by 0. Now we keep this here, and then we move this one over. So this becomes dy dx x cubed plus 1 raised to the power half is equal to -3x squared y all upon 2x cubed plus 1 raised to the power half. So Yeah, we divide throughout by this. Divide throughout by x cubed to get dy dx. So let's divide x cubed plus 1 raised by half. So this cancels this. So we write divide for us to write divide. We are dividing throughout x cubed plus 1 raised by half. So we are left with here dy dx is equal to minus 3x squared y all upon 2 in bracket x cubed plus 1 raised by half. From the whole, from BODMAS, this becomes 6 upon 1. 1 goes up and it changes sign. This is now bring down x cubed plus 1 from BODMAS plus 1 raised by half. From the rules of indices, this x cubed plus 1 and x cubed plus 1, they are the same. So we write one of them and add the powers half plus half. So this half plus half, you have half and half, it gives you 1. Half and half, if you solve this, half and half gives you 1. So we write dy dx is equals to minus 3x squared y all upon this 2 bracket, take one of the x cubed plus 1 and then you add the power half plus half from the rules of indices. So this one becomes 1. So dy dx now is equal to minus 3x squared y all upon 2x cubed plus 1. So remember, there is nothing here, so this is now 1. So let's try to complete this question. This is now, we cross multiply again. So here we take 2 multiplied by this, multiply again, and we leave this for us to prove our answer. So this one multiply here, so this becomes 2 in bracket x cubed plus 1 dy dx, and then we leave minus 3x squared y. So your answer, this is your answer. It has been proved. So this is how we go about solving this question. Please guys, to support the work I do, please make sure you like, you share, you comment, and then you subscribe. Thanks for watching. So in this question, we have to show that this here is equal to this side. So we have this y equals to this. Remember, we have here both y and x. So we're going to differentiate this using the implicit method of differentiation. And this is what we're supposed to get when we differentiate this. So let's solve this question. This is upon 1. Upon 1. And then you cross multiply. This multiply, y multiplied by this. And then 1 multiplied by this. You cross multiply. So this becomes y bracket x squared plus 5, and then 1 times x is x, cross multiply. Don't forget your rules of implicit differentiation. We expand this bracket first. This becomes x squared y times x is x squared y plus 5y is equals to x. Now, using the implicit method rule, we differentiate x squared, and then we keep y, and then we come again, we differentiate y, and then we keep x squared. So let's differentiate x squared and keep y. Differentiating x squared is 2x, and then you keep y. So we've differentiated x squared, we keep y. Now we write again plus. We differentiate now y. Now remember, this is y, so you differentiate y and then you keep x squared. You keep x squared, and then you differentiate y. Y will be dy dx. Whenever you differentiate y, it becomes dy dx. Plus, here again, differentiate y. This will be 5 dy dx is equals to differentiate x is 1. Let's try to solve again. We have to show that this is the first derivative, and from this question you have a second derivative. That means we need to differentiate this for the second time. So we're going to differentiate this result here for dy dx. We differentiate again for us to get the second differential, so we can get this value that we asked to show. So let's differentiate this again. If we differentiate here, let me explain this. This is 2. Let me put this in bracket. X, you differentiate x is 1, and then you keep y, plus differentiate y now, keep x. X, you differentiate y, becomes dy dx. Close the bracket. Plus, again, differentiate x squared, keep dy dx, and then you come, you differentiate dy dx, keep x squared. So now we differentiate dy dx, and we differentiate x, sorry, we differentiate x, this becomes 2x, x squared is 2x now, we differentiate it, and then we keep dy dx, plus, now we're going to keep x squared now, we are not differentiating x squared again, then we differentiate dy dx. Dy dx, redifferentiating this, it becomes d square y all upon dx square, plus 5, differentiating this again becomes 5 d square y all upon dx square. So 1 becomes 0 now. Differentiating 1 becomes 0. So this is now 2y plus 2x dy dx plus 2x dy dx plus x square d square y dx square plus 5 d square y all upon dx square equals 0. So we have here, collect like terms, this and this are like, 2x dy dx, 2x dy dx. So write 2x dy dx and 2x dy dx is 4x dy dx. So this is 2y plus 4x dy dx plus, again, you write this x square dy dx plus 5 d square y dx square, don't forget to write, equals 0. So let's write this to show the proof. So we are almost there. So let's write again x square now, d square y dx square plus 5 d square y all upon dx square plus 4x, rearrange this dy dx plus 2y is equals 0. Here we factorize d square y. So we're going to be left with x square plus 1 d square y all upon dx square plus 4x dy dx plus 2y is equals to 0. So this is our, sorry, this is 5. Factorize this x square plus 5, d square y is taken out. So this is what we have. So this is our answer for this question. Please guys, So don't forget to like this video. If you find this video useful, please subscribe. Thank you for watching.